Okay, so let's start with SERDE. Okay, so SERDE stands for, in fact, everybody knows that it stands for serialization and deserialization. Okay, this is simple, right? And nothing very rocket science. But now, why Hive needs SERDE? Right? What is serialization means? That whenever we want to write something to HDFS, so this is HDFS, right? Our file system, and we want to write something here, then obviously it needs to be converted to Java format or byte format, 000111, right? So here is our text file. We want to put it here, right? Or let's take another way. So we have our text file here, right? And we want to read into Hive, right? So the Hive don't understand, like this network, this obviously there will be a network in between, right? Because HDFS or Hive may be on different machines, right? So how data flows through the network? So when data flows through the network, it should be in 0, 1, 0, 1, 0, 1, something like this, right? So what serialization is doing, serialization is converting your TXT format or whatever different format, sequence format or any type of file. When we are reading data into Hive or any other software system like Hive, Spark, what SERDE is doing behind the scene to move the data through the network, it is serializing it. It is serializing it, right? And that's what called serialization. Now the question arises, what is deserialization? Right? So whenever we want to move the data from here, like data is converted here, right? 0, 0, 0, but we cannot read 0, 0, 0, right? So it needs to be deserialized. Making sense, right? And this is why SERDE is the most important property here, and even somewhere here, when we see here, okay, yeah, see this thing. I don't know what lazy SERDE or whatever different kind of SERDE is, but this is whole purpose of SERDE is serialization and deserialization, so that the data can be written into machine format, and data can be read by a human in human format. And this is whole purpose of SERDE and deserde. Maybe 000 is not the right example, maybe some Java bytes, Java bits or something, but this is what SERDE is doing behind the scene. Okay. I will cover SERDE in further details when I go for the specific files like Parquet file or maybe different file stuff, Avro or Parquet. I will cover it in other lecture. Today I want to cover something else. Yeah, I want to cover something related to the Hive queries. Okay, so let's say we have a query, right? Here somewhere. In fact, let's go here. I'm not running in Hive because I don't want to delay the session. So let's say we have show tables. Oh, it's very small, right? Zoom in and zoom in. Okay, so we have table here. So let's say I select star from customers, limit 10. So these are the customers which are in the customer table, right? So what these customers, now let's say if I ask you, tell me every customer who ordered something, only give me list of that customer, right? In how many customers we have into this table? Into this table, we have 12,435 customer. Now I want to see the count star of all the customers who placed order, right? So let's run it again, and I have one table called orders, and let's see what is there in order table. Limit 10. So sorry, it's not count star, it's select star. So since this came, so the total number of orders placed by these many customers are 68,000. Out of these customer, out of 12,000 customer, maybe somebody placed multiple orders, maybe somebody placed non-order, right? So we need to find the customers who placed orders. Okay, so let's select from orders. So something like this. So what we have here, that order ID, order date, order customer ID, the customer who placed this order, right? So now let's do one thing. Now we need to find the count of customer who placed order, right? So we can say where customer, what is that? Customer underscore ID in select order customer ID, order underscore customer underscore ID from orders, right? So what exactly is going on? This query, let it come. This query, it will be acting as a sub query, right? So now let's go there. It will take some time. Meanwhile, let's go here. So what subquery actually is? Subquery can be inserted or can be put into from clause. Like we can have something like, we have, how many clauses we have in select clause? We have select, from, and then where. So we can put subquery here and we can put subquery here. So the example which I gave you, I put subquery in the where clause, right? So let's see here. So right, out of 12,435 customers, only 30 customers didn't place any order. 12,000 customers placed order, right? So this query wasn't where clause, right? This is called subquery. So we can have subquery in from clause as well. How can we have subquery in from clause? Let's say, sorry, what's going on? Please. Okay, not sure what it did. Okay, so we can have subquery in from clause as well. So let's say we can have something like, if I want to see select, see, I'm writing everything in from clause. Subquery will always be in brackets. Subquery will always be in brackets, right? So I'll say select star from orders. I'm just doing some stupid query. It doesn't matter. So what I'm doing, select star from order as O, and I'll just say count star. Same thing what I did. So ideally what I did, I wrote a query in from clause. In that from clause, it is called inline view. So I'm not sure whether somebody is asking this question in interview or not, but when we use subquery in from clause, we call it inline view. Okay, so what I did here, I created a subquery in from clause. I named that inline view or the table as O, and then I counted that count star from that subquery. So this particular from clause subquery will act as a table, right? When we use subquery in from clause, the table, they will act as a table. When we use subquery in where clause, they will give you some values, right? So what we did here, so particularly this subquery, right? This particular subquery, what it is giving you? It is giving you customer ID, right? It is giving you order customer ID. Then what we're checking here, tell me all the customer ID who placed orders. So what I did, from the orders table, I selected order customer ID, and then I compared customer ID of customers table with order customer ID of orders table. So this particular query is giving you values. The values are order customer ID. Okay. So this thing is cool, right? So we can use subquery in from clause, in where clause. In where clause, it will give you some values. In from clause, it will act as a table. And sometimes you'll call it as an inline view. Okay. There's something called correlated subquery. there's something called correlated subquery. Let's try to write it. So here, if I use as I'll name it as C, as means I'm giving a name, aliasing it, where customer ID select customer ID where sorry guys, what I did, where exist. So it will be like where exists, select customer ID where, and let's call this table as O, where C dot customer underscore ID is equal to O dot order underscore customer underscore ID. Enter. Okay, so it's gonna be a bit faster than the previous, but what exist will do, exist will see, this is called outer query, right? This one is called outer query, this one is called inner query. But what I did here, I correlated outer query, that is this query, with the inner query. How I correlated? I correlated like this. So I referenced customer ID from customer table inside the inner query. Okay, this is called correlated query. So this will give us the count of every customer who placed order. This is the other way of writing it. See, exactly same result, right? Can you please zoom in the terminal? Okay.
Can you explain once again what is exist doing? Like we lost, the voice broke at that point.
Okay, no worries. So what exist is doing, see, what I write here in English, right? It's forget about SQL. So what I write here, that select count star from customers SC where exist. What exist? Where exists this particular clause? Tell me everything which, how many rows are returning true? How many rows are returning true out of this? So exist will evaluate in true and false, right? So what exist is doing, that select customer ID from orders where, okay, I need to zoom out a bit guys, because it is difficult to read for me. So what exist is doing, exist is comparing this particular where clause, and it is evaluating in true and false, and then it will feeding that query here. Okay, what the next question was? One second, let me see quickly. Then how does the inner query is executed first? Okay, now the question arises, which query is executing first? And it's a very, very good question. So according to you guys, which query should execute first? This one or this one? The inner query will obviously execute first and will give the result back to the outer query. Okay, so in terms of correlation query or correlated query, inner query will always execute first. And that's where, and why it's executing first, because see this, we are interfacing this customer ID inside the outer query. Okay, I don't want to go into so much detail, but yeah, this is how the correlation query works, right? Now let's cover one more topic here. That's called view. Since I covered the inline view, I just need to cover view as well. Okay, so something in Hive or in SQL terms is called view. Okay, so let's say we have orders table with 5 columns, right? And this customer ID is sensitive information. I don't want to share it with anyone, like with everyone. So what I can do, I can do something like this, right? So if I don't want to select order customer ID, then I'll say select order ID, comma, order date, comma, order status. Okay, so now order ID is gone. Sorry, customer ID is gone. So now let's say if I want to store this information as view means, let me tell you now. So let's say create view temp orders as this. Let me copy it and I paste it here. I hit enter. Okay, so now what I did actually, now to anyone whom I don't want to share the customer ID, because customer ID is PII, personal information or something, I don't want to share it. I will say, okay, you guys can access this table. So what I will say, select star from temp underscore orders. Same thing will work in Hive. Temp underscore orders. See now. So what exactly is view is? So view is just a select query which is running over the table. So the question arises, is this data stored in view? Is this data stored in view? No. This data is in table itself. View is just a select query which is bringing the data to you. So okay, now the next question is, why do we need views? Why do we need views? I have one slide for you guys like this. Okay, so I copied it from Dataflow website. So why do we need view? So for example, we have two tables, right? We have two tables, table 1 and table 2. As a database experts, we know how to join these tables. What is joining column? What is different kind of stuff? We wrote a very complex query. Now your manager just want to see aggregated data. What you can do, every time you can share that aggregated data to him, or you can share that select query with him, but he may get confused, right? So what in industry you will do, you will create a view, something like this, select whatever, column 1, column 2, column 3 from table 1, comma table 2, and on whatever, where, and some where clause, some very complicated where clause, and some and clause, and some n number of things. And then we will say create view as and this select query, right? So now for any person who is seeing this view, for him it looks like the data is stored in that table. So for any external person, view will act as a table. Okay, for him it doesn't make sense, or it doesn't impact where the data is coming from. For him, there is one table called, let's say, table 5, which has 3 columns. So to hide the complexity, for security reasons, for maintainability, different kind of reasons can be there to create views, right? Any questions on view, guys? So view is a best way to hide complexity, to prevent unwanted user to see the data, right? So let's say if we have 100 columns, 50 columns are very sensitive, some SSN number, credit card number, and it is only meant for admins. And if you want to share this data to each and every employee, so what you're gonna be doing, you will create a view, removing those columns, select only non-sensitive columns, and create a view called non-sensitive information, share with everyone, right? This is the purpose of view. The command which I showed you exactly work in Hive as well. Why I'm using in MySQL? So that it can run faster. Okay. One more thing what we can do, we can create index as well. But in Hive 3, the index are deprecated. But obviously we can create index on let's say we have millions of rows, we can create index on customer ID. Let's say if we have millions of customer. How we can create index? Create index salary, and then we can say which table we want to create index and which column we want to create index. I'm not covering it, but yeah, this is how we can create index, right? Okay. So now for what I covered exist, subqueries, views. Now let's cover this union all, and I'll be covering on TextPad itself. Okay. So let's say let's go here. So we have, okay, so let's say we have a view called temp_orders, okay, and let's say we create one more view. I'm doing this to show you the examples of union and union all, okay, where order_id is greater than 10, and we'll call it temp order gt10. So it means greater than 10. Okay, so now let me select temp order gt10. So it should have 11 to 20 rows. No, sorry, greater than 5. I want to repeat some rows. Okay, so I'll call it as, I'm creating one more view as gt5, whatever. So now I have two views. So in this view I have data from 6 to 15, right? In other view, that is table_order, I have 1 to 10, right? So let's say I want to combine both these tables. I want to combine both these tables, right? So what I'll do, select star from, in fact, let's do like this. Select star from temp_order, union, select star from temp_orders_gt5, right? So now what's going to happen, it will combine these two tables. So now the question arises, how many rows were there already? In temp orders we have 10 rows. In temp order gt5 we have 10 rows. Ideally there are 20 rows, but what happened when I do union, it removed all the duplicate rows and it only gave us distinct rows. That's first thing, right? So union will always give you distinct rows. Okay, now let's try union all. What union all did? Union all did all the rows, whether they are distinct, duplicate, it will just combine two tables, right? So this is how union and union all works. One more thing, what you guys have seen here, that in union this table is sorted like 1 2 3 4 up to 15, but in union all what it did, it took the first table, it took the second table, it just merged them one by one. So this is your first table, this is your second table, and it merged them, right? This is how union all work. In union there's a sorting, distinct data is there. In union all there is no sorting, and it just combined the table of data of two tables, right? Now let's cover intersect. So what intersect will do? What intersect will do? Intersect will give you the common rows. What is this going on? Intersect, how it's not working here? 1 second, guys. So, and let's see minus. Not sure why it's not working here. Just 1 second, guys. Intersect in MySQL. Ideally, it should work. I'm doing the same thing, right? Select category ID, maybe I did one thing wrong here. So I'll say order ID, and I'll say order_id. I'm not sure why it's not working. This is the correct syntax. Okay, but let me cover it now. What intersect will do, intersect will give you all the common rows. So in this case, 6, 7, 8, 9, and 10 will come in intersect. Like when I will do intersect, it will find what are the common rows in both the data sets or in both the tables, then it will show you. In minus, if we say 1 minus 2, it will minus all the common rows. So in this case, 1, 2, 3, 4 in case of minus, 1, 2, 3, 4, 5 will come in case of minus, right? In case of minus, what it will check, it will first check the common rows, right? So in table 2, what we have in table 2, this is the data. In table 1, we have data till 10, right? So 6, 7, 8, 9, 10 rows are common. So this is the result of intersection, right? And then in minus, what it's going to be doing, it's going to subtract the common result from the first table. So the common result is gone, means this 6, 7, 8, 9 from the first table is gone. What is the final result? It's going to be 1, 2, 3, 4, 5. Okay, this is how intersect and minus will work. View is covered, minus covered, everything is covered. The most important question which people are going to be asking you, difference between union and union all. So I covered that in a lot of detail, so please keep that in mind. Okay. Now the one more question for you guys. So how is union different from minus? Oh, how is union different from minus? I answered that question, or I need to answer it again. So minus will only give you these rows 1, 2, 3, 4, 5, but union will give you 15 rows. So minus is giving you only 5 rows, and union will give you 15 rows, right? So when we go union, this is the result. Union will give you distinct rows which are not duplicate across both the tables. Okay, and minus will give you all the rows minus the common rows, all the rows minus common rows. Okay. Yeah, perfect. So this is all about SQL queries. Let me cover one more thing here. Hive functions. I know yesterday you guys got confused, right? In aggregated or table definition functions, right? The user defined functions. So there are 3 types of functions, right? One is the functions which give you 1 row for each row, 1 result for each row. So I'm covering it again. So there are 3 types of function. Let's say we have 10 rows. When we run built-in functions, they will give you 1 row for each row. For example, upper, lower. So let's say we have 100 rows in which employee name is in lowercase. If you want to convert those 100 rows into upper, then there will be 100 result, right? Then their aggregated function, which will merge multiple rows into single result, the count star or sum or average, right? And then there is one more function called table generation function, which will work like other way. From 1 row, it will generate multiple rows, right? So now, yesterday I covered, I think, till aggregated function, built-in function. Now let me cover the table generation function. So we have one second. Just 1 minute. I have something here for you guys. This notebook and later. And oh yeah, so this is I wanted to cover. So I'll go here now. So what I have one table called collection underscore examples, right? Collection underscore example. Yeah. So in this table, I have 1 array and 1 map. So let's say I want data like 1 Java, 1 C++, like I want to expand this data with this ID, right? So how I can do it? I can do like this. Select, there's explode command for this. Explode. And then what is the name? Languages. LANG. So what it's gonna be doing? See what it did. It just exploded the full column, right? So it will explode it, the number of elements in array into number of rows, right? But when I put here, let's say if I want to know which ID has which language, then this won't work. What it says, that UDTFs are not supported outside select clause, nor nested in expression. So it means if we want to see UDTF, means user defined table generation functions outside select clause, we need to do something extra. And that something extra is called lateral view. Let me cover it now. So let's say if we want to use the lateral view, and this is the most asked interview question in the collections, right? So what are you gonna be doing? Select what I need to select, ID, right? And then I need to say new exploded column. So let's say new, I'll just say new underscore languages. I'll cover it in detail now. Let's say lang, and from collection underscore examples, right? From collection underscore examples, and then I'll need to say lateral view. So I'll just cover lateral view, and then I'll write the same thing, explode, LANGUAG languages. And what is my virtual table name? Let's say my virtual table name is new underscore L as new underscore lang. Let me run it, then I'll cover it. Okay. Okay, collection underscore example. Okay, so this worked, right? So what I did now, let me explain it in detail now, right? So when I was running this query, it was not working because it was saying that no, it's not by default functionality of UDTF, you need to do something extra. So what I did something like this and it worked, right? So what I did now, I selected the same thing, select ID and new language. What new language is? New language is explode of languages itself, right? Explode of languages itself. And then what I did, this lateral view and this collection example are two tables now. So what is going on behind the scene? What is going on behind the scene here? So this collection underscore example is the table one, okay, in which the real data is, or the original data is. What we did, we created one lateral view, right? What that lateral view consists of? It consists of explode underscore languages, right? What explode underscore languages is? All the rows, how many languages are there in the exploded form. We call that new table or lateral view as new underscore L. Now the question arises, from this lateral view, which column we need to select, or what is the output of this lateral view in terms of column? We call it new language, and then we say use this new language into the select clause here. This is how lateral view will work with UDTFs. Okay, any doubt? I know this is confusing, but if you want, I can explain it again. Okay, let me spend 2 more minutes on it. So when we explode this column, when we exploded the column, this result came, right? Then what I used in the lateral view, I said, okay, use this thing as a lateral view and join those two columns internally. Join those two, one lateral view and one the original table internally, and give me output like this. This is going on behind the scene. and I call the exploded column, and I called the new table or the lateral view as new L. Okay, this is what we covered the lateral view. Now one more thing which I need to cover is, let's say, and yesterday also I tried to cover the same thing. Let's say in Hive there is no function which is available to do your functionality. So Hive gave you power to write your own function, right? Hive gave you power to write your own function, and we call those function as UDFs, user defined functions. Okay, so now I try to write one function for you guys. So when we need to write UDF, you need to write it in Java function. So I write it here. So you need to open Eclipse into your Cloud or Quick VM, or anywhere where you have Eclipse installed, right? And let it open. So yeah, so when I share the slides to you guys, this site is very good for the explode and lateral view in Hive. This girl Swati explained it in very proper way. Okay, so it's opening. Okay, so meanwhile, let me explain it to you, right? So why we use UDFs? Whenever we don't have functions which can do our work, we can write our own functions, and we call them UDFs, user defined functions, right? In UDFs, so UDF can only be written in Java as of now, as far as I'm aware. Maybe in other languages also we can write, but I know in Java. So Java, when we need to write UDF in Java, first thing what we need to do, we need to inherit UDF class, right? We need to inherit UDF class first, and we need to override a function called evaluate. Only these two things we need to do. Import first of all, we need to do imports all, and then we need to inherit UDF class, and then we need to override evaluate function. I think it should be open now. Perfect. See now what I did. So here, if you see what I did, in the first line, I imported UDF from Hive QL executor, right? And I'll answer that question in 2 minutes. So first of all, I imported Hive QL exec UDF. It means I exported all the functionality of UDF. In the next line, what I did, I extend the UDF class from this library, right? And next thing what I did, extended UDF, and what I did, I overwrited the evaluate method of this class, right? I evaluated the override method of this class, and what I'm doing here, that if the string which is coming to this evaluate method is null, then do nothing, return null. But if the string coming to this method is not null, then convert those into uppercase. Simple. See, what I'm trying to implement here, two uppercase method or the upper method in the SQL. Behind the scene, it might have implemented like this, but this is how we want to implement, right? So what we did, we extended the UDF method first, right? And then we override the evaluate method, and we did some logic inside the evaluate method that, okay, if this string which we are passing in evaluate method is null, return null, else what we need to do, return the uppercase of that string. After that, what we need to do, we need to go here to my UDF, we need to export, one second, why it's not working. One second, guys. Okay, I'm not sure, it's slow for my machine. We need to export as Java, jar, next, and then we need to give some directory, and we need to export UDF there, and I already exported it, right? And once it is exported, and it should be, when we go here, in fact here, so where I go, cd home Cloudera downloads. So yeah, D is capital. So downloads. Then I do lsfn_ltr. So there is one test1.jar is there, right? So now this is here. Now what we can do in the Hive, and let me go here now. So we need to add this jar to Hive. I should have written somewhere. Oh yeah, this one. So now, so what? First of all, what we need to do? Create a class of user-defined function which extend this UDF and implements. We can implement more than one evaluate method. Put the reside logic, and you are almost there, right? Package your Java class into jar. What I did, right? Go to Hive CLI, add jar, and then create the temporary function. So what we can do here, let's see Hive. So we can, first of all, we need to add jar, and then we need to register our temporary function. I should have done it. So add jar, and once again, guys, I should have here add jar to Hive UDF. I don't remember the command. Sorry, guys. So here, yeah. So add jar name, jar path, and jar. Okay. So I'll go here. Add jar. What is my path name? Home. Cloudera, and downloads, and then test1.jar. Home Cloudera test1.jar. Okay, so I think I need to move it to temp folder. Okay, I need to move it to SDFS first. So Hadoop fs -put, and then what I need to do, I need to copy test1.jar, let's say, into TMP. And let's say TMP. Why it's not working? 1 second. So I did the same thing. not sure why it's not working. 1 second, guys. Should work. This is good. This is good. This is good. Add jar path to this create function. I'm not sure why it's not working. Okay, sorry, my bad actually, right? And then basically the single quotes were not needed, right? And I say so jars show, anyways. So now this is how you need to add jars. So you do not need to give the single quotes, okay? And then what we need to do, we need to create a temporary function and just paste it here. And what is my, so I'll go here and I'll say my UDF, my package name, and then my class name. So my package name is my UDF and my class name is my first UDF, okay? And I'll paste it here. Okay, and I'll hit enter. Okay, so what happened? The two upper function is created for me in Hive. So now I have select star from employee. Okay, so I have employees in, basically I should have other tables, show tables. Let's say I have one table called Google, right? Select star from Google. So in Google, I have everything in lowercase, right? So let's say if I want to cover, there's one column called wall. So let's say we have wall, comma, to underscore upper, the new function what I created to wall. So what it did, the last function, right, is this is wall function, sorry, wall column in the table. And what I did, I selected it into original form, and then I used my UDF, what I created, and it worked as a charm, right? So let me cover UDF again in 2 minutes. So to implement UDF, right, what you guys need to do, you guys need to create a Java class. The Java class needs to extend the UDF class from org, Apache, Hadoop, Hive, exec UDF, and need to implement evaluate function. In that evaluate function, you guys need to implement all the logic what you guys need to do. For example, into my UDF, what I did, I put some logic that okay, any string which came to my UDF, just convert it into uppercase. Okay, and then what I did, I created the jar by clicking the package. I go to export, I go to Java, I go to jar file, I go to next. I give the jar file as whatever, let's say I go here, downloads, and I create a test vendor jar. I created finish. Okay, and it will say it already exists. I say yes, let it be. Then I go to Hive. I edit that jar. The only mistake what I did was I put the single quote around the path. We should not put the single quote. And then I edit the jar, right? Then what I need to create a temporary function. To create the temporary function, it's so simple, create temporary function, whatever name you need to give. For example, I can give this name as Nilendra underscore upper, right? And we can give any name. And then what we need to tell Hive that this temporary function will be pointing towards this class and this this package and this class, right? So let's run it again. And then what I did, let me say Nilendra here, Nilendra underscore upper, and it worked. So what Nilendra underscore upper function did, which I created just as a separate function in Hive, it just converted that lower into upper. So let's say if someone asks you that, do you know how to write UDFs? You will say yes. We just need to extend UDF class, and we need to implement evaluate function or override implement evaluate function. We need to export jar and put it there. When do we mostly use UDF? Whenever the functionality is not, for example, when we need to do some complex logic. For example, let's say we have here, let's say we have an employee table, right? And we want to write a logic like this, that okay, if the department it's CS, we need to increment the salary by 5%. If department is ME, we need to increase by the salary by 15% or something complex logic. Then we can do that logic into evaluate function. Okay, because that function is not available in Hive as built-in. Okay, so this is all about UDF, UDAF, UDTFs. Okay. Okay, so this is good. One thing which I yesterday covered is difference between rank and dense rank. That's the most important thing you need to remember. And why I remember, because so let's say if you have 5 employees, the salary of those 5 employees is 1,000, 1,000, 900, 900, 800. What rank will do whenever there is any tie, it will skip the next rank. So for example, the first employee salary is 1,000, it is the highest salary, so the rank is 1. The second employee salary is the highest salary, the rank is 1. The third employee salary is 900. Ideally, his rank is 2, right? But what rank will do, rank will just say, since it has top 2 ranks covered, top 2 rows covered, it will skip the second rank and it will put it 3, right? Let's say the fourth employee salary is 900, it will put at 3, and in the tie it will put the same result, but the next row will be skipped. So ideally it should be 4, and since it is ranked, it will come as 5. Okay, so in case of tie, the next rank is skipped in ranking function. In dense ranking, the rank never is skipped. Okay. Okay, so Hive function we have covered, complex data type covered, view covered. Okay, can I spend 15-20 more minutes today and we can cover this partitioning? How many people are okay with it? Perfect. Okay, so what I'm planning to complete the Hive today, so that in the next session we can start something else. Okay, so now question arises that why we are doing this stuff, why we are going towards Hive, right? The answer is to do some processing, right? So in SQL, whenever forget about Hive, in SQL there are some best practices, right, which needs to be followed. Some of the best practices are, select only those columns which you need, put where clause wisely, don't go for aggregated function if you don't need them, lot of things. In the same way, there are so many things which can make your query and which can optimize the performance in Hive, right? See, so let's say you have a table with 1 million rows, 1 till 1 million, okay? And the table has 3 columns, and let's say the table has 3 columns: employee ID, employee name, and employee state. Okay, so ideally when you are running a query, so when I run, let's say the first employee is Nilendra, the second employee is Ram, the third employee is Monica, and Nilendra lives in, let's say, Florida, and Rams lives in New York, and let's say Monica lives in somewhere in New Orleans somewhere. Okay, so let's say if I want to run a query like select star from, let's say table is tab 1, from tab 1, where state is equal to FL, or in fact, let me say count star, so that I need to see how many people are living in Florida state. So what is going on behind the scene now? So we have 1 million rows. Let's say out of these 1 million, 500,000 people are living in Florida, right? So answer of this query gonna be 500K. But how Hive or the SQL, HQL did this job? What this query did, it start from the top, go till the end, and do something like this. Like maybe I'm not sure how it's doing, but it will do something like this. FL, if it is encountering the FL on the first row, what is it? FL, comma 1. Then if it encountered FL here somewhere, then it will put FL underscore 1 again, FL underscore 1 again, something like this, and it will scan the full table till the time FL underscore 1 come again. Then it will sum these reports, and it will say FL 500K, something like this, right? So what I'm explaining here, just to explore only Florida, it need to go for full table scan. Now the question arises, can we prevent this full table scans? Right? Can we prevent this full table scans? If yes, how? If no, why? Right? One thing you guys know, that Hive is just a structure onto the data which is present on the SDFS, right? So this table, tab 1, is just a metadata or meta store, just a structure which is pointing somewhere in SDFS, right? So let's say when I'm creating this table, I say, guys, or Hive, please store all the Florida location into one directory, all the Florida into small directory, NY into another directory, or New Orleans into one directory. So now when I run that query, that select star from table name where state is equal to Florida, my query won't need to run on the full table. It do not need to run the full table scan. It will just hit here and it will return me the query. So ideally, if I have 57 states in US, so I have 57 directory created in SDFS, and for each directory, I need to hit only that directory. For Florida, I need to go for Florida directory. For New York, I need to go for New York directory, right? So see, it's a very simple thing, right? And this is not rocket science. That, okay, if we need the data for some directory or some state, we need to store that data into one directory. So that full table scan can be prevented. Now the question arises, which directory or which column you need to use as for partitioning. Let's say we are calling it partitioning, right? What we did, we partitioned our table based on the state. This, let's say we call it a partitioning. So on which column we can do the partitioning? Which column has low what we call cardinality? So what cardinality is? Cardinality. So cardinality means which has limited values only, low cardinality, right? So let's say we have 57 states, we can have 57 directories, but can we have partitions with each employee? Let's say we have 1 million employees, right? So can we have directory created on each employee basis? No, it's gonna be having 1 million directories. 1 million directory means our name node is gone. It will be too heavily burdened that when you run select query in Hive, or when you want to interface with name node, the result may come in 25 minutes, right? Or maybe more than that. And it's not suggestible, it's not the best practice to create extra or low cardinality or low granular directories into the name node, right? So now the one thing is low cardinality column should be used to create partition. The second thing is most used columns in where clause should be used for partitioning. If I'm using frequently where state is FL, where state is NY, where state is New Orleans, where it is blah, 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 then that column is eligible for creation of partitions, right? In this case, this is the most eligible column to create the partitions, right? So the partitions are directories behind the scene. When you create partitions, they are actually partitions are directories behind the scene, which stores the file for you. Okay. So what I did today, I created a table, this table. Oh, sorry. I created this table for you. Okay. Now let me go here and to the Hive. This is MySQL. And this is Hive. So what I say, so underscore tables, right? So what you can see here that I have multiple tables. The ordered tables, this table is normal table, no partitions. Okay. So when I say show, what is the command? Describe formatted orders. Okay, so what did it say? It has no partitions, right? It has nothing. So it's a normal table and detailed information database, but it has no partitions into it, right? Then what I did, I created a new table, orders underscore static underscore partitioned. Okay, before I cover there, let me cover the partitioning can be of two types, right? The partitioning can be of two types. So let's say you know that there are 57 states in US. So what you can do that you can create a table like this, right? And when you put data into this partition, and since you know that there are only 57 states, you can, while you insert data into this table, you can say insert this data into this P1 partition. So every time when you are inserting data, you are telling Hive, please insert in P1, please insert in P2 partition, please insert in P3 partition. So you are giving this partition like this. When you are inserting data, so you are telling Hive, okay, insert data into this partition. Okay, so this is called static partitioning. Now the question arises, when you go for static partitioning, when the value is very, very low, like the cardinality is very low, maybe 10, 15, 20, in which you can mention it and you can maintain it, right? But the cardinality, let's say, is 100 or maybe 200 or 500, we will go for dynamic partitioning. Now what dynamic partitioning is? Dynamic partitioning is you will tell Hive that whenever a new column occur in the partitioning column, so let's say we are partitioning on state, right? We are partitioning on state. You will say insert into table, and whenever a distinct value come into the state column, create a new directory. So let's say when FL come, it will create FL here. When NY come, it will create NY in the SDFS. When NO came, it will create NO. Now again FL came, it won't create a new directory, but it will put the data here. When NY again came, it will put the data here. So it is dynamically creating directories for you and dynamically putting data inside those directories. Okay, so there are two types of partitioning, static and dynamic. Okay, so now we have orders table which has raw data. Now what I did, I created few more tables, right? Let me show you now. So I created two tables. One table I created static partition table. One table I created dynamic partition table. Okay, so let me show you static partition table quickly. So when I say describe formatted this table, let me show you now. So what, see, everything is same, But one thing which is new here is partition information. This thing is new here. So what this table is telling you, that this table has partition based on order status. Okay, so now the question arises, how many order status are there? So I will run a query here. Select, one second guys, distinct order status. So right now we have 9 distinct order status into the orders table. Okay, so ideally, since this is static partition table, right? This is static partition table. So let's say if I want to insert data, let me show you one more thing. Let's say if I want to insert data into this table, right? Let's say if I want to insert data into this table, so what I need to do, first of all, let me show you what I did. Hadoop fs-ls, paste here, and user Hive warehouse. So I already put data for, I think, 1 or 2 types of order status. Order underscore static under partition, not sure what's going on. Okay, order underscore partition. Yeah, this one. One second. I will just cover static partitioning today. I may cover dynamic partition in the next session. Okay, so what I did, I just put the data for order status is equal to complete in this partition, right? And let's say if I want to put other data, let's say for other status data into this table, what I need to do, I will do something like this. I will do something like this. I'll go here and I'll say load data in path. Okay, what other thing I did, let me show you one more thing. So what I did, that I have all the data into my SDFS directory here for all the status types. So when I go for this year, I created this data today just for you guys, so that we can do. So for example, what this temp directory, temp test data directory has all the data of different status types, order status types. So right now, what I did, I kept this data, right, complete. So I complete data for the status is equal to complete. I put it into the table. Now let's say if we want to put table for status is equal to pending. So that's it. So what we need to do, so we can put here pending. So this is what we are doing in static partitioning. We need to do always do something like this. So every time when you need to ingest data, you need to put manually the directory in which you need to put, or the partition in which you need to put the data, and the file from where you need to put the data. Okay, so here when you created this table, right, when you created this table, you mentioned that okay, this table is partitioned by order underscore status. So whenever you need to create a partition table, you need to put partition by clause, and you need to put the column on which you need to create the partition. So I created, right now, just forget about static, I was doing something. So I created one table called orders underscore partition, and this table is static partition, and I'm inserting data into static partition. Now, one more important thing before I jump here to insert data. So order underscore status, we gave in where we gave in partition by clause, right? We never mention it in column clause, right? But when I describe this table as normal, not as this, in fact, so what it did, it is Hive is considering this column as normal column. Hive is considering this column as normal column. For Hive, it doesn't matter whether it's partition column or normal column, you know. So when you say select, you can select the partition column as normal way. That's what I'm trying to say. Order underscore status from this table. You can select any partition column as a normal column. Hive doesn't segregate it. See, it came, right? So now let's say if I want to put data of pending status into that column, what I need to do, I'll go here and I'll say something like this. Okay, see how fast it is. So now let me explain one more thing. What it did, it created a new partition. When I say new partition, it created a new directory behind the scene for you. How many files it put in the directory? It put one file. What is the size of the directory? This directory, right? So now let's do one thing. Let's go here. In fact, let's go here. Orders underscore partition, right? So right now, what I have seen that there was only one directory. This directory was inside that. Just before I run the command. When I run this command again, Hadoop fs-ls warehouse directory for ordered partition table, it will give me now two directories because it's a new partition. If this table was not partitioned, the data will come inside directly inside the parent directory. But now, since we have partitioned the table, for every partition, it is creating a new directory. Okay, so let's say if we want to go inside this, so this is a directory name. It's a directory name, right? So I'll just copy it and I'll go here, I paste it and I'll hit enter. So see, what is the directory name? Hive created a new directory with order status is equal to pending. And inside the directory, it put one data file. So now, if I go to Hive and I'll say, select star partition where star from order part, this, right? Since it's string, I'll put a string here. So what this select, oh, see how fast it is, right? Now let's do one more thing. In order table, the order table was not partitioned, right? So when I run the same command in order table, it was status partition. See, what I'm trying to say here, that when it is a partition table, it will only hit that directory. It will only hit the particular directory. Since the data is not allowed here, that's why I'm not able to present you the performance benefits. But when it is partition table, it is only hitting that particular directory. So when I'm running this query on partition table, it is just hitting this particular directory. It is not touching even this directory, the other directory. Am I making sense, guys? So this is the biggest benefit, that data has been segregated and we are hitting the particular directory. Now, any other question on static partitioning? So let's say if I want to ingest data in cancelled status, right? So what I need to do, I need to go here. I need to change my command. cancelled, and same thing I need to put here. C-A-N-C. And when I run it, it will create a new directory for me. Now when I go here, so I paste it here. One thing, sorry. What's the spelling cancelled? Yes, C-A-N-C-L-E-D. C-A-N-C-A-L-E-D. C-A-N-C-L-E-D. Okay. It's done. One second, what's not? Sorry, guys. Just 1 second.
You're missing a single quotation.
Oh, yeah, sorry. Okay, here, right? So test data. 1 second, let's go here quickly. This is the last topic. So load data in path order cancelled. Let's correct the spelling first. And then partition is equal to cancelled. And here also the same thing. Control Z. Okay. So it should be, I'll copy from here now. Copy. I'll paste it here. I'll paste it here. Run it again. So paste. Okay, I know the mistake. Let me tell you guys quickly. So when you go here, ls-ltr test data orders. So I know what the mistake is. I didn't create the directory with the correct name. So I use the double L here. See, this is how we need to debug code, right? So now I mistakenly put double L here, right? And so what I need to do, I need to go here. I need to put double L here, okay? And double L. So it will work now. So when I go here and run it now, it worked, right? So that was my mistake when I imported those directories. So when I go here now again, and I go here, it should have created a new directory for me. Okay. And now one more last thing. So it created a new directory with cancelled order, right? So now let me show you one more last thing. When we say show partitions for which table? For order underscore partitioned. Insert into table order underscore partitioned. So paste. So it has 3 partition into it. What these 3 partitions behind the scenes are, they are 3 directories. Inside these 3 directories, we have data files. And when we go for where clause with order status is equal to cancelled, it will just hit that directory. And that's the beauty of partitions, that it will prevent the full table scan. It will only hit the particular directory. Okay. So this is how static partitioning works. And you now know the pain in static partitioning. Every time you need to insert data, you need to mention this directory name, you need to mention the path, and that's why static partitioning is only useful for a very small amount of data. For this case, when we have only 9 rows, we can do for static partitioning. But if you have 90 rows, obviously the thing which I'm trying to do and I was explaining, it's gonna be tough for you guys, right? For anyone. Let's cover one more thing. So I have one table called dynamic partitioning. See, whenever we are creating static partitioning or dynamic partitioning, behind the scene, everything is same. Behind the thing, everything is same. The only thing which is changed is how we are ingesting data, right? So what I'm explaining you, that these 2 table structures, these 2, Control Z. So what I'm trying to tell you here, that the static partitioning table creation and the dynamic table partitioning table creation are almost same. We nowhere mentioning the Hive that this is dynamic partitioning or this is static partitioning. The only thing which we are telling Hive that please ingest data in now dynamic fashion. We need to do something like this. We need to enable some properties into Hive when we ingest data in the dynamic way. So what I do, I just copy it here. I'll go here into Hive and I'll enable these two properties. By default, they are false, but now I have enabled them. Okay, and now the most important, the most easy thing what I need to tell you. See, when I run this command, insert into table, order partitioning bucketing, which partition? This partition, order underscore status, from where select star from orders. Then what this will be doing, in fact, let me do one thing. Just in 2 minutes, I'll go into Hive, drop table, and I'll create it again for you guys. Drop table, this table. I'll create it again. Paste. Okay, so this table is gone, means data is gone as well. There's nothing. And now what I did, I'm creating this table again, just to give you the demo. Okay, so for you guys, there is nothing changed. We just changed the name of the table, but the command and everything is not changed. So what we did here, we created a dynamic partition table. On which column we are partitioning? We are partitioning order status. Okay, and now what we need to do, we already pasted these two commands. We need to go for dynamic partitioning. What we are telling here that, okay, we are telling Hive that, okay, please set dynamic partitioning is equal to true. And please set partitioning mode is equal to non-strict. For this use case, what I'm telling you, this is not applicable, but yeah, let it be. Okay, so this is not applicable for single partition. If we have single column partition, this is not applicable, but let it be. Okay, single column partition, not applicable. Now, in this table, how tough it was for me to ingest data. For every time I was doing cancelled, I was doing some status here, I'm putting status here, right? Now see how dynamic partitioning works. So where's that? Control Z. Now this, I'll copy this command. It's a normal insert command, right? And I'll paste it here. So it is doing everything for me now. Okay, let it run, and I'll show you something else after this. Meanwhile, let's go here and just copy this thing from here. This is the table name here, right? So let's go here and so that is running, and I'll paste it here. So right now there should be nothing here. There should be nothing here, right? Or maybe some temporary directory. It's taking time. Why it's taking time? Because see, there's nothing here, right? Right now, because the job still must be running. So job is still running, right? So what it did here in the, oh, one more thing I need to tell you. Static partitioning was very fast, right? Very, very fast. So when I run the static partitioning, it is running in milliseconds. But when I'm running dynamic partitioning, it is taking a lot of time. Why? Because Hive is doing so many things for me. It is figuring out which column I need to go for, which directory I need to create. If the new record of the same directory comes in, I need to put in the same directory. So it is doing a lot of things what we did, you know, in the static partitioning. And that's why this is taking too much time. It is running a map reduce job. It is doing some logic for us, and it is creating directories for us, right? And this is why static partitioning, we are doing a lot of work on behalf of Hive. And for dynamic partitioning, we are not doing anything. We are just ingesting, writing a simple insert statement, and Hive is doing everything for us. Okay. It's taking too much time. So now see, this is doing map and reduce, and number of reducers are 4, number of mappers is 1. So that's why it's taking time. So it will, map is completed here, and the reduce will be completed in the next run. So it is also taking time. So now the question arises when you will go for dynamic partitioning and when you will go for static partitioning. In most of the industry cases, you will never go for static partitioning. If your columns are too much low, for example, 4 or 5 distinct value, you might go for static partitioning. But in industry, most of the cases are dynamic partitioning only. To do the dynamic partitioning, you need to tell Hive first that, okay, we need to do enable the dynamic partitioning is equal to true, and something like non-strict mode if we have multiple column partitioning. Okay, let's go here quickly. This is done. So now let's read the logs first. What Hive did for us, the same thing what I was doing, Hive did the same thing for us. So it created 9 directories with order status is equal to suspected fraud and all the order statuses, and it put all the records from orders table and put it into the particular directory. All the completed order status record will go here. All the payment reviewed order status will go to this directory. And this is why when we go for dynamic partitioning, it is taking too much time. Now, when I go here, it should give me 9. 1 second. Okay, my bad actually. Anyways, so I put in the wrong table because I was practicing something, and that's why the data is not coming. So I'll do here just to show you guys. Paste and so it should have 9 different columns. See, so what this guy did, it found 9 items and it has 9 different directories. Inside these 9 different directories, we have data. So now when we, in the where clause, when we run status, order status will be cancelled, it will just go to this directory. When we run order status is equal to suspected fraud, it will only go to this directory. So what we prevented using whether static partitioning or dynamic partitioning, full table scan has been prevented. And that's why the query will be super fast. So in this case, the query time will be 9 times lesser because only we are going for the 1/9 of the data. And that's why the partitioning is super helpful. Okay, so I think that